This is day 2 of Advent of Code 2023, and this challenge is called Sand Slabs. Enough sand has fallen. It can finally filter water for Snow Island. Well, almost. Sand has been falling as large compact bricks of sand, piling up to form an impressive stack here near the edge of Island. In order to make use of the sand to filter water, some of the bricks will need to be broken apart, nay, disintegrated, back into freely flowing sand. The stack is tall enough that you'll have to be careful about choosing which bricks to disintegrate. If you disintegrate the wrong brick, large portions of the stack could topple, which sounds pretty dangerous. The elves responsible for water filtering operations took a snapshot of the bricks while they were still falling, the puzzle input, which should let you work out which bricks are safe to disintegrate. So for example, I've got 101, 121, and so on. Each line of text in the snapshot represents the position of a single brick at the time the snapshot was taken. The position is given as 2 x, y, z coordinates, one for each end of the brick, separated by a tilde. So each brick is made up of a single straight line of cubes, and the elves were even careful to choose a time for the snapshot that had all of the free-falling bricks at integer positions above the ground. So the whole snapshot is aligned to a 3-dimensional cube grid. So this line would mean that both ends of the brick are at the same coordinate. So in other words, that the brick is a single cube, while this one and this one both represent bricks that are 2 cubes in volume, both oriented horizontally. The first brick extends in the x direction, while the second brick extends in the y direction. A line like this represents a 10 cube brick, which is oriented vertically. One end of the brick is the cube located at 0,1, while the other is 0,10. The ground is at z0 and is perfectly flat. The lowest z value a brick can have is therefore 1. So 551, 561, and 0 to 1, 0 to 5 are both resting on the ground, but 332, 330 was above the ground at the time of the snapshot. Because the snapshot was taken while the bricks were still falling, some bricks will still be in the air. You'll need to start by figuring out where they will end up. Bricks are magically stabilized, so they never rotate, even in weird situations. Like when a long horizontal brick is only supported on one end. 2 bricks cannot occupy the same position, so a falling brick will come to rest upon the first other brick it encounters. Here is the same example again, this time with each brick given a letter so it can be marked in a diagram. So on the XZ axis we got A here. Assume this is 1, 1, 1. Alright, so 0, 1, 2, 0, 1, 2, so 1, 1. And then I assume this one goes vertically up 2. Okay, this is now the Y Z axis, so 3. Okay, 0 to 2, so 3 like that. And then this one is the inverse, where it's X 1, 2, 3, but then Y is just 1, or 0 I should say. Okay, so that's what each of those look like. So G is got an 8 and 9 there, so Z is like that. And then on this one should be the exact same, which it is. Okay. So once all of the bricks fall downward as far as they can go, the stack looks like this, where question mark means bricks are hidden behind other bricks. So for this one, these stay the same, but then the C1 can go down, because they're on different y-axes. So 3, 3. Now different y-axes means they can go kind of in line with each other. So I assume that's what that is. On the side, yep, you got B, C like that. Okay, so then now that all the bricks are settled, it becomes easier to tell which bricks are supporting which other bricks. Brick A is the only brick supporting bricks B and C. Brick B is one of the 2 bricks supporting brick D and brick E. Brick C is the other brick supporting brick D, brick E. Brick D supports brick F, E, F, F, G, and G nothing. So your first task is to figure out which bricks are safe to disintegrate. A brick can be safely disintegrated if, after removing it, no other bricks would fall further directly downward. So don't actually disintegrate any bricks, just determine what would happen if, for each brick, only that brick were disintegrated. Bricks can be disintegrated even if they're completely surrounded by other bricks. You can squeeze between bricks if you need to. So this example, A cannot, B can with C supporting it, C can with B supporting it, D can with F supporting it, E can with D supporting it, F can't, and then G can. So in this example, 5 bricks can be safely disintegrated. Figure out how the blocks will settle based on the snapshot. Once they've settled, consider disintegrating a single brick. How many bricks could be safely chosen as the one to get disintegrated? Okay, that's interesting. So we'll grab this input first, and so we're going through each line for the bricks. We need to separate that. Let's take a look back at this. The fact that the Z is used for vertical is kind of confusing me a bit. Usually it's a Y for vertical, but okay. So we'll start off, so for a line, then we need a split on tilde, and then we need to, so we're splitting on tilde, then we need to, I don't know, for brick in lines on that. Then for XYZ in brick dot split on comma, we do int XYZ, make this tuple. We'll change this to tower. Okay, let's run this and see what the output of that is like. Okay, that's not what I was wanting. I'm not sure how that happened. Okay, let's take it a step back. What does brick look like? Why is it doing generator object? What? Does this need to be a list? Okay, I guess it needs to be a list. Okay, there we go. So we've got each brick and each XYZ and then XYZ. We'll change this so it's actually a function. Initialize tower, and we do this because we don't want to have to redo all that when we're in the next part. So tower equals this. So we've got our tower. So I guess looking ahead, so we'll create a function which is for drop, which is basically drop everything, and then we will do drop brick, which will be for dropping individual bricks, and then def find, what is it called in this? Defined disintegratable. I think that's how you spell it. I'll just assume it is. So for drop, we'll be passing it tower, and that'll be drop tower. And then this will be for brick in tower, drop brick, and that will be like this. Let's take a quick look at what the actual input is like. Oof, okay. Okay, as we can see, this is not in order, which we need to make it. So we will need to sort through tower. So we'll do tower equals, this will be, is it always smallest to tallest like that? It appears to be. So I think this should be sorted. Would this be tower, and then key equals lambda brick 5. Okay, so that's unchanged, but let's try it with real data just to see if that's correct. Okay, I think that's correct. I think we do want it from those numbers. So how is it doing these numbers? Oh wait, so right, not that one, this one. Okay, yep, smallest to highest. I think that's really confused me. This is the different XYs. Oh, it's that the like this is using, like I would have thought this was XY and ZY. Like I'm not sure why they're doing it on the Z. It's like to fall downwards. It doesn't. I don't think it ever says which dimension you drop it on. Okay, yep. So it's Z-axis where it's dropping on. So for drop, we need to keep record of the brick that is currently at the highest point for a certain XY area. So what's the best way to do that? I think keep like a dictionary of dictionary, or maybe a range from like a certain XY to another XY. Then you store the height value or the Z value for that one. Okay, so we will have tallest as a dictionary. This will store the XY coordinates, basically the whole range of a brick, and then XY, XY, XY throughout it, and then we'll store the Z value for it. This is something that's going to be passed into drop brick, so we'll pass like that. So for brick and tower, we'll do dropped brick equals brick. But okay, now we need to actually do the dropping. So we need to search through. So we need to search through the XY coordinates of this brick, going through the tallest dictionary and finding the highest Z value that would be like below the brick. So it might have like 1, 1, 1, 1, 2, then a 5 here. It would go on top of that. So we will do highest equals. So we need to do for X in range brick 0 up to brick 3 plus 1. So from the lowest side to the highest side. And then we also need to do for Y in range, basically the exact same thing, but now it's 1 and 4. And then we need to do tallest dot get X, Y, and if it's not there, it'll be 0. So we've got all the values, and then it'll be max. Make that a list like so. First thing we need to do is calculate the distance that has just fallen. So distance equals, so will be, what will this be? So it's gonna be this part, brick 2, which is, so it's going to be like this, the lower Z value, which is on top of the brick. So it will need to be brick 2, which is be minus highest. I think that's what it has to be. Then return basically brick 0, and just rebuilding all the bricks. So 5, 4, 3, 2, 1. But then it'll be brick 2 minus distance, brick 5 minus distance. Okay, probably should do some math for this. So let's say we got, say we have this one and this one. So we've got brick 6. The difference, okay, we need to, okay, we'll quickly finish. So brick 6 minus 6 would be the highest. So that'll make it 2. But if we do minus 6, minus 2 will make it 6. So we need to do minus 1 for that. So that will drop it to the highest point. So now for here, we've now got the new dropped brick. And we should probably, what do we do for this? So I guess the first thing we do, we'll add the new brick to the tallest. So we'll do tallest, actually we'll do for x in, actually we might be able to just copy this code. Oh, not that one, this one down here. So for x in range that, for y in range that, tallest, oh actually I'm not going to bother trying to do that. Let's just do for x in this range, then same thing but y in 1, 4. We will do tallest xy equals new brick, dropped brick, 5. So that's the highest point. So we're now recording that, and then I think we need to create a new tower equals list, and then new tower dot append dropped brick, then return new tower. So new tower equals this. So this is everything that has fallen down, and then we need to figure out, actually probably should print tower, print new tower. Left these ones still in. Does that match up with this? I think it does. So we've got 5, 1, 1 like that. Put the G there, and row 2 and 3 have, so 2, 2. This one dropped to 2, 2 as well. Then we've got 3 and 3. Okay, so that does look like it's working. So what we now need to do is figure out if we remove a brick whether it causes something else to drop. So a way that we could actually do that is by rerunning drop. Was if let's say we remove a brick from the tower and then we run drop, we can see if any of the bricks actually move. So that is something we're going to have to also record. So I think that is the approach for this. So we've got new tower, and so we need to create we'll create a new list of the new tower, which has the one that we're currently doing removed. So we'll do for I in range length of new tower. We'll do removed tower equals new tower 0 up to, I can just do colon I, and then plus new tower I plus 1 onwards. So we've now got removed tower, but then we also in here need to record if it's fallen. So for brick, drop brick. Actually, let's do if brick equals dropped brick, print same brick. So I just want to see if that works. So let's comment this out for now. Else we will print brick dropped brick. Okay, so that's why that's not working, because it's this one I'm doing a list. Okay, we'll just change this to a list because I was having issues before getting that working. Okay, good, same brick, that works. So if doesn't, we will do fallen equals false, fallen equals true, and then we'll just return fallen like that. So tower, new tower. So we don't need fallen here. And then for this one, got remove tower, then we do fallen equals drop remove tower. And how are we actually recording this? If it was, could be safely. So it'll be total equals 0 if fallen total plus equals 1, and then it'll be return fallen, turned false, so that's because I'm meant to be returning fallen. Only 2 apparently. Okay, so which ones? So if I want to also do print I. So 0 and 5. Okay, well that's wrong. Out of curiosity, if you do equals. Okay, yep, fair enough. But really, 0 and 5, so 0, actually I don't know if it is in that exact order. 0, 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. Wait, how is that possible? So it should be like that. Let's print brick, dropped brick, and we will print I here. And we'll also print new tower I. So if we look at the input, so if we remove that one, this happens. Wait, this looks like it is working. So where's 2 coming from? Print fallen. So true, false, false. Oh, okay, I've got it the wrong way around. If not fallen. There we go, 5. Okay, let's remove all these prints. So we've got 5. Now to time to change this input. 403. There we go, that is part 1 done. So now on to part 2. Disintegrating bricks one at a time isn't going to be fast enough. While it might sound dangerous, what you really need is a chain reaction. You'll need to figure out the best brick to disintegrate for each brick. Determine how many other bricks would fall. If that brick were disintegrated, using the same example as above, disintegrating brick A would cause all 6 other bricks to fall. Disintegrating brick F would cause only 1 other brick G to fall. Disintegrating any other brick would cause no other bricks to fall. So in this example, the sum of the number of other bricks that would fall as a result is that. Okay, that sounds easy. So we're going to change this so brick equals 0, and this will be plus equals 1. And we'll do if, I think that would say the same, 403. So for part 2, basically grab the same input. Let's just run it there just to make sure it's all working as expected. Okay, it is. So now, so I guess in this case it's just if fallen, total plus equals. So let's change it back to this and run it. If not fallen, okay, I did the wrong one. So firstly, if fallen, it should be plus equals fallen, 7. Okay, now we'll do real input. Part 2, so 403 for the first one, and then 70189. So submit that, and awesome, that is day 22 of Advent of Crow 2023 completed. If you like this video, make sure to like and subscribe so you can watch me complete the rest of these videos, so you can watch me complete the rest of these challenges.